to Apocalypse Now, the podcast where I dive into some of the most devastating environmental disasters and explore how we can prevent them from happening again. I'm Holly Stower. I'm an environmental researcher and advisor who's worked with big name companies to develop sustainable solutions and solve their environmental challenges. I've spent a couple of weeks researching the many ideas to clean up the Great Pacific Garbage Patch and also considering if we should even bother. And if you haven't listened to the previous episode, that's where I outline what a colossal disaster the Great Pacific Garbage Patch actually is, as well as what it is and why it is. So I'd recommend going back and listening to that first. But as a recap, the Great Pacific Garbage Patch is the world's largest accumulation of ocean plastic that we know about. It's a huge floating soup of small plastic kept there by ocean currents called gyres. And where these gyres are, plastics are trapped in this underwater vortex. There are 8 major ocean garbage patches that we know of, and initially the waste is thought to be from plastic waste, littering. Recent findings have actually found that up to 80% of the plastic is actually from fishing boats discarding nets, oyster pots, baskets, etc. While this is an absolute shit show for marine life, with ghost catch, smothering, ingestion, smaller plastics are also getting back into our food system, with plastics found in human blood, placenta, and that can be linked to infertility and other major health problems for people. So today I'll be looking at what can be done to clean up the garbage patch and whether we should even bother, what can be done to prevent fishing plastics from being dumped, from tricky policies in the somewhat lawless open ocean to innovation that can both prevent plastic waste in fishing as well as clean it up. And if you're asking what you can do about ocean plastics, I'll leave you with some powerful actions that you can take. So, there are so many solutions that exist for plastic pollution, from changing the formula of plastic and making it biodegradable, to using alternative materials. Some cool examples include using milk waste, seaweed, or even just paper. Plastics can be recycled, and there are advanced recycling methods which produce more high-quality plastics. Also, innovations which produce less toxic byproducts in the process. And there are solutions to support the wider recycling industry, such as smart recycling bins, incentivized return schemes, and autonomous waste sorting robots, which really ensure that more stuff gets collected and more of the stuff that's collected is actually recycled. But few of those actually have a direct impact on the Great Pacific Garbage Patch. So I'm going to talk about companies and solutions which are actually clearing ocean waste, and technologies such as vessel tracking, small underwater robots that can actually police for illegal fishing. So let's start by addressing the first question. How can we clean up the Great Pacific Garbage Patch? Well, that comes with a number of challenges. Firstly, its size. It's estimated to be over 1.6 million kilometres squared, so roughly half the size of the European Union. It's massive and it's dispersed. The NOAA estimates that to clean up less than just 1% of the North Pacific Ocean would take 67 ships, 1 whole year to clean up that portion. There are greater concentrations of plastics within the gyres, and organisations such as the Ocean Cleanup have developed a computer program to map this and sort of predict where they can make a significant dent in the garbage patch by sending their ships to focus on an area where they know there will be a high concentration of plastic. The other issue is that the waste will just keep accumulating in this area if we don't stop the flow of plastic. The patch is growing at about 2.1% annually, with up to 86% from fishing activities. There's also a vulnerability to greenwashing that I'll come back to. So the idea that in having sort of low impact activities that look really impressive, you that are being funded by the plastic polluters themselves, you look as if you're doing a lot whilst doing very little and keeping on business as usual. And finally, there's also a question of whether the ecosystem would even be better off if it was cleaned up. And what I mean by that is, so in May this year, I was doing a dive internship called a Dive Master in Indonesia. The shop that I did that in is called Oceans 5. Shout out to the amazing people at Oceans 5. So every other week, some of the instructors, dive masters and some volunteers would do a reef clean. You'd head out in scuba gear to clean the local reef outside the shop of plastic, which had accumulated over the last fortnight. It was a really great place to do it because it was next to the pier, so all of the waste would sort of get pushed and pulled and trapped in that sort of area. It was also a bad place for that, as it would collect a lot of silt. So as you clean up the waste, you might disturb the silt, it would be harder to see. And at best, that would reduce visibility for a few meters for a while. And at worst, which happened to me, you lose your bearings entirely. You also had to be really careful of marine life. So if you tipped out a container or if you found a bottle, you would check inside and see if there was anything hiding so that you wouldn't take that out of the environment. It was also quite dangerous for yourself. There's an octopus called the blue ring octopus, which is teeny tiny, but it holds enough venom to kill like 26 people. So we wore gloves. But to the point of this, where sort of nature takes over. So there was this point that's hard to explain, but you would see a plastic bottle or a crisp packet that had like a film of algae or limpets on, and this might have been forged into the coral, or even significant algae is growing on it, so you don't want to really take that. The other one, there was a resident damselfish that was very protective over this one giant chip packet, so you'd leave that as well. You'd have to make this judgment call of whether it's a good point to clear it or whether it would do more harm than good by clearing that waste. So it stays. There were exceptions to this rule, so we talked about ghost catch. If there was any fishing line or nets, someone would take, at least 1 out of 2 people would take a line cutter, so you could just cut that line and leave it so nothing would get entangled. So the same idea of sort of nature taking over, scientists have studied this in the open ocean, where the Great Pacific Garbage Patch is. It's a completely different environment to these coastal and reef ecosystems. So the open ocean was thought to be completely devoid of life, like an ocean desert. But in the 1950s, a Soviet research vessel took samples across the North Pacific Ocean. They found an entirely new class of organisms, which included nudibranches, jellyfish, snails, barnacles, hydrozoans, of which the Portuguese man of war is a member of. If you've ever seen those very dangerous, really blue, it's not a jellyfish, hydrozoan, that have awful stings. Yeah, I thought they were jellyfish, but they are hydrozoans. So these organisms were classified as Neuston. They live in the open ocean, and at least for some part of their life cycle, they may also have no ability to move, to alter their direction. So they spend their entire lives at the mercy of ocean currents and sort of living in this thin space between the sea and the sky. The floating Neustonic organisms are living among the trash. Like the plastics, they are pulled into these gyres and kept there. So whenever we try and clean up this trash, we could collect and kill these really unique organisms. And we don't know how important they are to other creatures, to the food chain, to ocean health. Does the harm in killing them outweigh the harm reduction of removing the plastics? So a 2024 study into Neustonic life in the Great Pacific Garbage Patch found 2 very important things that may inform future cleanups. So 1, The density of Neuston life are not higher in plastic hotspots in the Great Pacific Garbage Patch, meaning clearing these hotspots will have a greater impact in the amount of trash collected, while having little or not lesser impact on the Neustonic population. Neuston life also has significant seasonal variability, so further harm can be reduced if clearings are done at certain times of year. So, for example, avoiding spawning season, where if you did a big clear up and there was an area where there was loads of babies or juveniles, you could end up clearing and killing an entire generation. So, okay, it can be worth clearing up plastics in the Great Pacific Garbage Patch, provided you follow the rules. Focus on hotspots, avoid critical times for Neustonic life. So who's actually clearing up ocean plastic in the Great Pacific Garbage Patch? And the first name which comes to mind really is the Ocean Cleanup, who I've mentioned a couple times in these 2 episodes. They operate like their namesake. They have also conducted significant research on the Great Pacific Garbage Patch, using its many plastic recovery missions to undertake that research. They are an NGO. They have a goal to clean up to 90% of floating ocean plastics by 2040. Their funding comes from large corporations such as JP Morgan, Coca-Cola, as well as from many individuals. They also have academic partners to enable them to conduct the many pieces of research that we've discussed. And the company uses that funding to develop for-purpose equipment and vessels to intercept and capture ocean plastics. So the funding also contributes to their many missions to collect and recycle ocean plastics. One of the most exciting sort of research to innovation missions which they've undertaken is with rivers. So really interestingly, rivers are described as the arteries of plastic waste, which carry waste from the land and to the ocean. They are the main source for ocean plastics. And surprisingly, the research that the Ocean Cleanup undertook found that only about 1% of rivers are responsible for over 80% of this plastic, meaning even more effective targeting of ocean plastics. So in putting 2 and 2 together, the Ocean Cleanup have developed technologies to block this river plastic. So they've operated in Guatemala's Rio Las Vacas. So every rainy season there brings this tsunami of trash, which has become one of the world's most refuse polluted rivers in just one generation. And it's responsible for around 2% of total ocean plastics from rivers. So to tackle this, the Ocean Cleanup use their technology called the Interceptor Barricade. And this works using 2 floating barriers or booms, and they look like huge floating mesh fences, supported from behind by blue barrels. The first one, placed upstream, which takes the brunt of the force, it intercepts most of the plastic and waste being carried by the river. And these booms have to take on such a force from the waste-laden and fast-flowing water that they are chained to foundations dug deep into the riverside and set in concrete. Then, further downstream, there's a second boom, and this one acts as a safety net, catching anything that the first one might have missed because of the sheer volume and speed of the debris. So together, they make this site one of the most effective spots for pulling plastic out of the water before it can make its way downstream and then into the ocean. The trash can then be collected by many large diggers that are on the riverbank and then disposed of correctly, recycled. This is one of many interceptors that Ocean Cleanup has in place, including one in Indonesia, which has been in place for 6 years. And there's one in the works for Bangkok and another in Mumbai. So looking globally at where next to intercept ocean plastic from rivers, the Ocean Cleanup have identified that the worst polluting rivers were in the Philippines, with 466. This is followed by India with 211, Malaysia with 105, China with 139, and then Indonesia with 105, and the list continues. So, to prevent plastic waste entering the ocean, the River Interceptor presents a really, really promising and highly targeted, as well as relatively low-tech option. It just needs funding. So the ocean cleanup also carries out several ocean missions, focused specifically on the Great Pacific Garbage Patch. It uses huge ships and nets to collect floating plastic in these high concentration zones. These are also huge projects and require funding. And it seems that they have been largely government and corporation funded, boosted as well by charitable donations, but more long-term funding is needed. Many of these countries already have significant waste challenges. They usually have an informal waste sector, poor collection rates, improper disposal. So funding is needed across the board, and not just at these river sites or cleaning up once it gets into the ocean. I would suggest a polluter pays tax like that has been suggested for Hong Kong. So for example, companies like Coca-Cola or Nestle would shift from making charitable donations to having to pay a tax on every bottle sold to fund its cleanup. The government takes that tax and then allocates the money accordingly for the cleanup. The Environmental Investigation Agency is also skeptical of the ocean cleanup, as well as other ocean cleanup technologies. Previous funders of the ocean cleanup have included major plastic producers or plastic polluters, including Sabic, Coca-Cola, and plastic manufacturer DSM. So again, these cleanup operations require big budgets, while their tangible impact and the visceral imagery of a huge ship collecting huge amounts of waste make for really great PR, and so is vulnerable for greenwashing. They enable an opportunity for funders to show their big impact while they carry on with business as usual, producing plastic which ends up into the ocean. Cleanup operations are also resource intensive. You need fuel to run these big ships, and while the ocean cleanup offsets their fuel use, and we could get into the rocky ground of comparing one environmental ill to another, this fuel needs to be considered as one weighs up the environmental benefits of the technology. Fuel use needs to be considered as one weighs up the environmental benefits of these technologies, especially if we were to scale it up and go full in on ocean cleanup technologies. One way to reduce both emissions and manpower is using autonomous renewable powered vessels. One company, Clear Robotics, they also focus on rivers, large lakes and coastal areas. They've developed a small, fast, cleaner robot that can clean small areas. Its ClearBot Class 2 can collect up to 200 kilograms of waste in one go, whilst also employing AI and GPS to make its cleanups targeted and more efficient. Its other robot, its ClearBot Class 3, is a higher capacity solar-powered, zero-emissions, autonomous waste collector. This can be used for larger lakes, rivers, and coastal areas. This is capable of collecting around 500 kilograms of waste in one go. So the vessel can operate for longer and sends real-time data on waste collection, whilst also providing water quality monitoring and data, as well as precise draft surveys. However, when we're talking about the Great Pacific Garbage Patch, this would be less appropriate for really large areas and in remote locations like the Great Pacific Garbage Patch. Another solution is from a company called Seabin. They're based in Sydney, Australia. They have developed an autonomous floating plastic filter. It uses solar power to draw in about 1.3 million litres of water per day through its plastic filter. It's a bit like a giant mussel or a bivalve filtering water to intercept the plastic. Seabin intercepts and captures microplastics, fibers, oils, and fuel residues, and it can hold up to 20 kilograms of waste. I think this is a really interesting solution for harbours and ports, and these guys, or Seabin, is used in Sydney Harbour. They use 9 Seabins and to success. But again, for the Great Pacific Garbage Patch, they require frequent emptying and they can only hold 20 kilograms of waste. So what I would recommend is that cleanup activities, they should be part of a comprehensive approach to ending plastic pollution across the full life cycle of plastics. And of course, it makes more sense to turn off the flow of plastics entering the ocean. For example, if your bath is overflowing, you turn off the tap rather than start bailing out the water. But the ocean isn't a bath, and there are dangerous plastics in the ocean. So these cleanups need to be considered, done well, and really applied where the good outweighs the risks. And you can use zero emissions vessels that are a lot larger. These are in development, but large cargo style or low emissions vessels have really yet to reach commercial scale, or are they commercially viable for this application? Again, these are charity funded missions, and using a super innovative low emissions vessel would be super expensive. So it's likely we'll have to compromise on environmental benefits for these vessels appropriate to clean up the Great Pacific Garbage Patch for some time coming. So can we focus on stopping the flow of waste? Previous research has shown that an estimated 80% of the waste in the Great Pacific Garbage Patch is originated from the fishing industry. So this presents an opportunity to stop the flow of waste. And technologies can enable us to do this. So I have found a number of options, and here are some of the cooler ones. So we can avoid fishing in the sea altogether. If we want to still eat fish, then we can focus entirely on fish farming or aquaculture. Aquaculture is fish farming on land or on pens in the ocean. This is a very well-established sector, and in 2021, aquaculture accounted for about half of the world's fish, and this exceeded 50% in 2024, overtaking capture fisheries for the very first time. The sector will also continue to grow, along with the expected population growth and increased consumption, the rise of the middle classes, and growing consumption of fish products. However, some fish farming is very unsustainable, and it also doesn't necessarily avoid wild-caught fishing. So carnivorous fish like salmon and tuna, which you find, well, for the tuna you find and fish in the Pacific Ocean, where the Great Pacific Garbage Patch is, these fish require significant feed, and usually from fish meal. And fish meal relies on the overfishing of small, nutritious fish stocks. Fish farms also produce significant waste and pollution, which generally isn't cycled back into the ecosystem, like which would naturally occur in the ocean. So similar to industrial farmed meat, these fish also need antibiotics, antifoulants, and other harmful chemicals that can leach into the environment. And again, like livestock, some are also genetically modified. When these fish can escape into natural environments, and they can alter the natural balance and outcome of the native populations, or they can overconsume resources, or they can introduce disease as well. So, aquaculture is problematic. It's also very energy and water intensive. Habitats need to be cleared to make way for these farms, while the industry also has a history of poor labour conditions and displacing small-scale fisheries. And fish farming is pretty cruel as well for the fish. It is important to note that all fish aren't farmed equally, or seafood aren't farmed equally. So mollusks or mussels, oysters are filter feeders, and they also enhance water quality. And so they end up being one of the most sustainable animals you can eat, depending on your sustainability metrics. They can be placed in areas with high pollution and can improve the water quality whilst maintaining a very good meat and being one of the lowest carbon meats that people can eat. However, mollusks don't produce the fishing waste in the Great Pacific Garbage Patch. So for the big unsustainable fishes which can be farmed in aquaculture, so for example, the tuna, there are a number of technologies which are seeking to help clean up problems in aquaculture. So companies such as Kidemis from Switzerland, they're creating alternative feeds for the aquaculture sector to avoid the wild-caught, unsustainable fish meal. So Kidemis grow mycoprotein, and that is fungus grown on waste such as agricultural waste. So you take a waste product, you grow this fungi that provides significant amounts of protein and then feed it to the fish, avoiding the nasty, wild-caught, unsustainable fish feed. Some companies are also looking to address the energy and water intensity of aquaculture with systems like recirculating aquaculture systems or RAS systems. So these are closed loop systems where fish or other marine species are raised in tanks. So water is filtered to remove gases and solid wastes. It's then purified and then recirculated. Efficient systems can reuse more than 95% of water. But RAS systems also allow more fish to be farmed. And with higher densities, this brings a greater risk of disease and health issues. Some companies are then looking to tackle this using AI to optimize and manage the RAS facilities. So companies such as Real Data, they embed computer vision cameras to monitor fish biomass and ensure automated smart feeding to reduce human errors and also reduce the energy and water use. So sustainable aquaculture can and does substitute wild-caught fishing, albeit at great expense. And again, I would not deem mainstream aquaculture a sustainable swap for wild-caught fish. However, some technologies do improve the environmental footprint of practices, and I'm a big fan of leaving the CDF alone. And if that means imprisoning generations of mutated, genetically modified sad fish, then all right. Ideally, the world would eat less fish, but I'll get back to that. So we're veering off topic. So let's return to looking at technologies to prevent ocean plastics in the fishing industry. Let's start with nets. Lost nets are an environmental disaster to marine life. Most nets are made from plastic, they don't biodegrade, and as we spoke about in the previous episode, lost nets are one of the most harmful types of marine debris. They're designed to catch fish, and they will continue to do so, trapping, starving, and killing them until they're removed from the ocean or they sink. And this is called ghost catch. These entangle dolphins, whales, other marine mammals while continuing to catch and kill fish. And I think even if they sink, they will still continue to catch and kill those fish. Lost nets are also an economic challenge for fishing communities. A lost net may mean that the fisher people, it's very hard not to say fishermen, will go home empty-handed. Nets can get trapped in ship propellers, and they can also cause delays or slow down a ship, which they then need more fuel to move. Is to live on a houseboat, and you'd regularly be able to feel if there was something on your propeller. Everything would feel really sticky. You'd have a tiller that you'd move. Everything would feel really sticky. It wouldn't feel like you were able to move more efficiently. And then in that case, you'd have to pull the boat over to the side or tie against another boat, lift up the hatch at the back. I'd take a bread knife, have a look down, and usually you'd feel it in the propeller, and you'd literally have to saw off. I think I sawed, mostly it was plastic bags, a lot of plastic bags. No nets, as there's not any fishing in the London canals. I think I sawed off a pair of trousers once, and ropes, so many ropes. But yeah, first-hand experience that getting stuff caught in the propeller causes you to use more fuel and absolutely slows you down. But lost nets, it's a huge problem. It's estimated that 5.7% of fishing nets, 8.6% of traps and pots, and 29% of fishing lines used globally are lost. They're either abandoned or discarded in the ocean. Ghost gear can also destroy marine habitats. They can break precious corals, and they can disturb marine sediment. And marine sediment can hold a lot of carbon, and once that is disturbed, it releases that carbon into the atmosphere. That's why trawling is so awful. Trawling is where you basically drag a net from the bottom across the ocean floor to catch everything up from that water column. Many fishing vessels are also running blind when they launch nets into the sea, so they don't know if what's underwater. So their net can get caught on an underwater obstruction. This can lead to the fishing crew having to ditch both the catch and the net. Recently I went diving in Zanzibar. I've been very lucky to be able to mostly dive in marine protected areas, but this was not one. So there was small scale fishermen, and it was only men. They launched these huge nets over the top of corals, which was sad. And as we were about 8 to 10 meters deep, we could see this net underwater. They also were using a team of snorkelers in the water to prevent any snagging, and so that their net wouldn't break significantly and they could continue to catch the fish. While it was really cool to observe and see, it was sad for a diver, and I did try to coax a porcupine fish out from under the net. I wasn't successful. But no shade to subsistence fishing communities, fishing in their own waters. They have lived like this for many years, and these are practices and communities that need protection. The real issue is when it comes to industrial fishing. But my point is that this method of snorkeling to prevent snagging isn't feasible in deep waters. And net loss is often a lose-lose dynamic for everyone. So with this in mind, in June this year, the European Union funded this project called NetTag. They ran a technology trial together with the Sicilian fishing community in Italy. So NetTag uses acoustic tags, which are small, low-powered, sound-emitting devices. And these work by emitting a unique ultrasonic waves, and they can be picked up by another sensor, usually placed on the boat, called a hydrophone. These sensors were then attached to the nets, trammel nets. And trammel nets is like a 3-layer net designed to entangle sort of small to medium-sized fish. And then once that was deployed by the fishers, they used the hydrophone to see if the net could be detected. And it was. So the second stage of this trial included one of my favourite bits of ocean technology, a UAV. UAV is an autonomous underwater vehicle. This one that they use was designed by robotics engineers at Insatec. They're based in Portugal. And this UAV, called Iris, it used sonar sensors to identify lost fishing gear at depths of up to 500 meters. Not yet to retrieve the net, which I thought would be like the coolest application if these UAVs could grab the net as they go. but as I understand, robotics with embodied manipulation, meaning that they have the motor skills to enable it to interact with the environment, are super expensive and in early stages of development. But in this case, it was deployed to gather more information to support future net rescue. And looking at NetTag Plus's website recently, it seems that they do have plans to deploy UAVs to assist in removing nets, which is very exciting. So NetTag Plus is one of many examples, and a great example of some brilliant minds working together with the fishing communities to solve this problem. And they really see fishers as future guardians and cleaners of the sea, and plan to pilot a promotion and reward scheme for anyone that would volunteer to clean up nets. This is in early stages of development, and as with all innovation for net tagging and retrieval to really have an impact, it needs to be scaled up rapidly. To do that, they will need to be cheap enough and easy enough to use, and there also needs to be external drivers to encourage their use, either carrot or stick, to encourage this subsequent removal of the nets. The other issue with net tagging is that it assumes that nets and traps are lost by accident. This is not the case. So while accidental loss is one factor for lost nets and traps, even if fishers can locate a net, it's often too heavy, damaged, or the weather is too bad to retrieve it. It may remain there until ocean currents dislodge it, and it may make its way to the Great Pacific Garbage Patch. In industrial fishing, which is the likely main culprit for the waste in the Great Pacific Garbage Patch, they use drift nets and long lines, which are often deliberately cut loose if they interfere with navigation or they become unmanageable, while traps and pots may be thrown overboard once fishers move to new grounds. The other issue is around illegal fishing, which we talked a little bit about in the previous episode. The US Coast Guard estimates that about 20 to 30% of the global catch is attributed to illegal fishing, so around 1 in 5. Many of these vessels will lose gear on purpose by recklessness or purposely dumping. So to avoid detection, they operate at night or in bad weather or without access to safe spaces. So gear can easily get lost. If they spot the Coast Guard or other monitoring vessels, they may quickly dump their gear to avoid detection or dump it to gain access to a port. There are some really great regulatory recommendations that I found that could be implemented that aren't yet. So one is making the marking of fishing gear mandatory. So a simple solution where discarded gear can be traced back to its owner. 2, certifiers of seafood products which deem if and how sustainable practices could have been adhered can include gear management in the standards, which could incentivize fishers to improve their gear management. So, for example, in 2022, the Marine Stewardship Council, the MSC, updated its fisheries standard to require fisheries under its assessment to monitor and retrieve lost gear. To support this initiative, MSC certified seafood is something that you can look out for in the supermarket, and it looks like a fish with a tick. And the third way is to better monitor for illegal fishing. So the final technology I want to talk about is another autonomous ocean vessel, a USV, which is an uncrewed surface vehicle. One company I've spoken to a few times is Open Ocean Robotics. They are based in Canada and they've developed a solar-powered ocean drone. It's capable of traveling for up to 40 hours non-stop and can be launched on missions of up to a year. This has zero fuel costs and it's estimated to be about 90% cheaper than mainstream alternatives. On board, it has a customizable suite of sensors able to map the ocean floor, listen for marine mammals, and also aid the enforcement against illegal fishing. The USV also has a 360 visual camera for day and nighttime surveillance, And this is also supported by AI for vessel detection and identification. It also has what is known as an AIS detection system, autonomous identification system, which is used around the world to track vessels. So this can be hijacked or spoofed or turned off by vessels. So using both this detection system and the camera, the USV can identify if a vessel has turned off their AIS system, but the camera can still see it and identify that there's a vessel there, giving a strong indicator that that might be an illegal vessel. So basically, this robot is an underwater ninja / Inspector Gadget patrolling the high seas. And the company have done multiple successful monitoring missions together with wildlife charity Wild Aid. And after detecting illegal activities, this information can be and is passed on to local authorities to prevent poor practices or illegal fishing from taking place. However, technology can only deter and may even exacerbate dumping practices if illegal fishers get spooked about detection and dump their gear. So, I have discussed just a few of the many solutions that can prevent, deter and clean up ocean plastics and prevent ocean plastics from ending up in the Great Pacific Garbage Patch. I would also like to discuss technologies in alternative materials, especially the prospect of biodegradable nets, computer vision on nets, and smart fishing nets, where only a certain type of fish can be caught. But I hope to cover these in future episodes. We can look at some of the many fishing disasters that have existed. But none of these solutions in their current scale I would classify as high impact. I'd say the most promising is probably the river barricades. And for fishing fleets, I'm excited about the community-led solutions to incentivize ghost net clear up. And completely agree that fishing communities are the stewards of the sea and should be empowered and rewarded for clearing up the sea. And as with most climate technologies, none of these are silver bullets and they need to be implemented well. The environmental benefits weighed up against the potential environmental ills, and they need to be scaled up accordingly. This all needs government buy-in. It's difficult with ocean technologies because you have international waters, you need lots of different governments working together, and lots of different industries working together to make these solutions effective. Also needs funding and consumer demand, so make sure to check out in the supermarket for sustainably caught fish if it's a wild caught fish. And assuming you're not running an illegal fishing fleet or you're the head of product design for Coca-Cola, I'll leave you with 2 asks. Again, do look out for the MSC certified fish or your local equivalent. And consider replacing your tuna dish with some mussels or oysters. They're packed with my favorite vitamin B12. And also just try and be more considerate of your own plastic use. Do recycle. It really does make a difference if you clean and wash out your yogurt pots. In the next episode, I'll be looking at more ocean technologies and looking at the 4th mass global coral bleaching event. This is a disaster which is ongoing today, and it threatens all life in the ocean. But there are some really cool companies that are looking after corals, growing new corals, and preventing damage from the corals by doing crazy things like making clouds in the sky. So do check that out once I post it. It's going to be great. And I'd love you to hear your thoughts on this episode, the last episode, feedback on the episode. If you'd like any questions answered, do you have any questions? Have you had personal experiences connected to the Great Pacific Garbage Patch or ocean plastics? Have you or your community ever lived through an environmental disaster? I'd love to hear about it. And what does prevention mean to you? So you can reach out on Instagram at Apocalypse Nope, or by leaving a comment wherever you're listening. I will leave some links in the show notes on how to connect with me, as well as the sources I've used for these 2 episodes. So don't forget to subscribe. I'd really appreciate it. Leave a review, share. Helps more people find the podcast and join the conversation. I'm Holly Stower. This is Apocalypse Now. And remember, stopping the apocalypse starts with understanding where it begins.